Hi, Georgios, are you there?
Hello, can you hear
Hello.
me?
We're going to wait a couple of minutes because it started to rain and some people were on their way to the auditorium. So let's wait a couple of minutes and we'll let you know when to start. Okay?
So, hello everyone. Welcome to the last day of the conference and the last session. So in this session, we're going to have 4 papers. I think 1 short paper, 2 long papers. The last one I forgot. But let's welcome the first speaker. The first paper is going to be titled Making the Familiar Unfamiliar, AI-driven synthetic metaphor generation for computational creativity. It will be presented virtually by Georgios Pamas. I think, Georgios, you can start.
Hello, everyone. Thank you for being here. I'm really glad to be part of this conference and to share some of my thoughts with you today. I'm also looking forward to your thoughts and questions on what I'm going to present. So the topic is about using metaphor as a technique for computational creativity. And my apologies. Okay. And I would like to start with this image by Dora Maar, which depicts uh, essentially 2 objects, a seashell and a hand, and both of them are common objects. So what makes this uncanny as an image is the context. So it's the combination of these two objects in this image. Putting them together, they can provoke curiosity, sometimes confusion. Uh, but this essence of uncanny is also the essence of a metaphor. So the main question is, metaphor is very a cognitive function, a human cognitive function. And the question is, can you use the machine to generate metaphor that makes sense, that can be particularly useful for our task at hand? So a metaphor is about thinking in an abstract way, is about dealing with complexity, and it's about generating new ideas. Essentially, this is the main objective. So we often treat metaphors as a decoration, so something that is poetic, something that is beautiful, but it's optional. But this is not real because metaphor is about cognition per se. So when we say that we understand time as a river, this fluidity, or fear as a shadow, this structures our thought and link and makes this link between the abstract and the familiar. So that's why AI metaphor generation really matters, because if machines can generate metaphors, then it's not about imitating language, it's more about engaging in a form of conceptual reasoning. And this is just a technical challenge, because there are also other questions, deeper questions, like can AI think creatively, and what happens when it does? So metaphor is the intermediate. It's something that transforms our experience, what we already know. So through the metaphor, we get a new understanding of uh, our experience. So that means we can have different meanings, different understandings for the same experience. And we would like to know if we can do the same thing by using AI. So in this example, you can see an object of an everyday object, a very common object. And this is a cheese grater. And it's obvious that this is also a hedgehog. So we can recognize the shape of this animal. And there's a metaphor there because the back of the hedgehog is very rough. So this makes the connection between the utility and the form of this object. So this is how someone will use a metaphor, specifically if we consider this example in product design to generate something new. So the essential idea behind our metaphor engine is the synectics. Synectics comes from the Greek word synectikos, and that means bring together things and discover their link, how these objects can get together. So it's not about the object, but it's about the connection between these objects. So we use synectics to trigger these mechanisms that are catalytic in order to create new thoughts, new ideas, or new inventions. So we're using 4 analogy types, and these are also our creative triggers based on the synectic theory. And these are namely direct, personal, symbolic, and fantasy. And there are some examples that can make this connection with more creative processes. So direct can be also a combination of different objects, and symbolic can be something that you can build a myth based on this. So its metaphor type we used isn't arbitrarily generated. We use these triggers, these 4 design triggers, in order to unlock, let's say, the AI imagination. So by adding this into, let's say, GPT-4 prompts, we give the model not just a vocabulary to play with, but a way of forming something metaphorically, the same way humans do when designing or storytelling. So let me pause for a moment and simply show you what thinking metaphorically looks like in forms. We already seen the image of the hedgehog, cheese grater. There is an image of Man Ray with the glass beads, and this association generates something new, a different kind of feeling. We have an image of architecture as sharing ideas from biology, and of course, this very immediate, direct connection between the human body and the tree.
Hi, sorry to interrupt. You have 2 minutes left.
I'm sorry?
Oh, you have 2 minutes left for your presentation. Just a reminder of time.
Yes. So, how we generate the metaphors. So this is the overview of the process. First, we use themes. We have 10 different themes like fear, dreams, memory, and then we use these 4 different synectic triggers. And based on these triggers, we generate metaphors based on prompts for ChatGPT. We also have a handpicked and also curated metaphor corpus from different cultural sources, and this is our base for comparison. And we evaluate by using 3 metrics, using BERT to calculate the coherence, novelty based on TF-IDF, and creativity, which is self-evaluation by ChatGPT. So here are a few metaphors, sample metaphors, and a human metaphor, time is a thief, for the theme time, and the AI, based on a fantasy trigger metaphor, time is a god juggling destinies. So it sounds nice, it sounds like a metaphor. So what was the result of this research? What we learned? The machine can be somehow, or it looks like, can imitate creativity, and but there is no balance between structure, and that means fantasy analogies, as you can see, scored the highest because they stretch associations farthest. But they also suffer the most incoherence. Direct analogies are safest because it's about familiar things and coherent, but these are less novel. So this suggests that creativity coherence trade-off is there, which synectics at least help us to navigate. And themes like dreams and knowledge can encourage AI GPT to invent, not to repeat. In contrast, themes like power or love which is more abstract, but also very saturated with cultural cliché, um, leads to more safe, more familiar outputs. So this reinforces the idea that abstraction can help, can boost originality, actually. So what are the implications? How someone can use this approach, this method? A few examples are creative writing. In education, when you need to explain something, and using a metaphor can help actually uncover the meaning. And creative industries, I think that this is quite familiar approach, but not with AI tools, not yet. So it can be used for design and branding and co-creation. And that means having a human on the loop and using the machine so as to boost the creativity of a human. And I have this nice image here, which is from a student of mine in computer graphics that made this metaphor of normals, and normals are these vectors emanating from the shape of a 3D object as being the hair of the object. And this really helped the students understand what is that. So this is a very good use of using metaphors so as to understand something complex. So limitations, first of all, bias, and we need a way to tackle this. How useful is this metaphor? I think that the usefulness comes always when the human is on the loop. So human needs to control the process. And we have human metaphors from cultural sources, and we have metaphors based on ChatGPT, and there is serious overlapping sometimes. So there is the cultural memory as well shaping the generation of the metaphors based on the AI. So that was my presentation. Thank you very much.
Thanks for the presentation. Any question from the audience? So I guess I'll take the chance to ask the first question. So the title of this paper says about turning the familiar into unfamiliarity. So in this metaphor creation process, you talked about coherence, you talked about creativity. Which part is the unfamiliar part? Is it the creativity or something else?
Familiar. I think that the essential first stage is always to make a collection of the objects to be used, tools. And then it's about trying to find the connection. And most of the time, this is an exhaustive process, like a brainstorming. And a metaphor is something that can trigger specific ways of thinking. And it's also part of the uncanniness, the same uncanniness we feel in surrealism, in humanoid robotics as well. So it's this weirdness. So that means things are familiar, but when combined together, they resonate in a unique way or strange ways.
I see. Thank you. If there's no more question, I have another question actually. What was exactly the prompt you gave GPT for generating those metaphors?
I'm sorry, I didn't hear you very
Oh, I'm
well.
sorry.
There is too much echo. Could you please repeat?
Yeah, so what was the prompts you give GPT for generating those metaphors?
What was the prompt?
Yeah.
Yes, we used 4 different prompts. We designed the prompts. Actually, there were lengthy prompts. We used 4 different prompts based on these 4 different synaptic triggers. And we experimented a lot with this so as to have some kind of consistency. And we have a few examples of these prompts in our paper. So you can refer to this if you want a few examples of that.
I see. Thank you. If there's no more question from the audience, let's thank the speaker again.
At the University of Sydney, and I just want to mention this work is work that I did as part of my honors, more or less, but I've since moved to university, so that's why I'm presenting it from the University of Sydney. But let's move on. So before we start, I would like to acknowledge the Gadigal people of the Eora Nation, the traditional custodians of the land on which the University of Sydney stands, and pay respects to the elders past and present. So the motivation for this work arose from suspicions I had about conversational interfaces with AI. So generally, when you're conversing with LLMs, you have this linear step-by-step method of interaction. So you give it a question, it gives you an answer. You give it a question, and it gives you an answer based on all the information you have before it. And I thought, does this process, I had a suspicion, does this process make it difficult to explore or branch out to different ideas? And I wasn't quite sure, but that was kind of the motivation. So the kind of solution I thought, okay, maybe, and this is because I come from a background where I've looked at graph node interfaces and I find them interesting. So I thought, oh, maybe if we treat each node as a prompt, instead of treating each prompt as just a step in a conversation, we could branch off these prompts and have an interface that is a bit more, you could call interactive, bit more creativity allowing. So these type of interfaces, graph node interfaces, graph-based systems aren't a new thing in AI. There are a variety of them that already exist. So AI chains is an example of such an interface which kind of inspired this work. Now what they do is they break a given prompt into a bunch of smaller problems, and they use those smaller problems to actually complete the task. So this is kind of a node interface where each problem is a node, and it allows for intermediate controllability and stuff. And because you're giving more information about your problem to the language model, they found that you get much better results. There's ChainForge. This graph node interface looks at evaluating language models, so you can create pipelines to evaluate or compare two different language models. There's LangFlow, which is just the visualized version of LangChain. Some of you might have heard about LangChain. It's just I guess, it's a very popular Python library for dealing with agents, prompts, etc. And there's PromptChainer. This is a pipeline to prototype AI apps. So if you look across these type of graph node systems, what you find is they're specialized to specific tasks, and they require some domain knowledge about AI and ML to actually operate. They're not as simple as having a conversation. You cannot just enter a prompt and connect a prompt to another prompt and have a similar kind of easy interaction for an everyday or a casual user. So I thought, okay, let's move on to develop an easier system that's graph node based and see how that affects creativity. So there were 3 key design principles we looked at. One, we wanted to support divergent thinking. This is the branching off I'm talking about. We wanted to keep it simple. We didn't want the person to know much about how LLMs work. So we didn't want to expose a lot of the underlying API that something like Langflow exposes. And we wanted to have a free process where they don't have to do a bunch of rigid steps. So with these design principles in mind, we developed a system with 4 different kind of nodes. These are very simple nodes. A text input node is just a node where you can enter some content. A prompt node is a node where you have the prompt and it gives you an AI generation. A context prompt node has the additional ability to add context along with a prompt. So you might want to treat the actual action you're performing in the prompt differently to the context associated with that prompt. So that's what this type of node serves. And then there was a way to visualize text through stable diffusion. And to execute these nodes, what you do is you sort them topologically. Essentially, you do a breadth-first traversal while keeping a heuristic on the location of the nodes, and you can execute them in order. If you detect cycles in the graph, you can give an error and say, we don't want cycles in the graph. And this is an example of what it looks like. So on the left-hand side, you have this sidebar where you have the different options for nodes. You can develop custom templates of nodes. So once you have a configuration of nodes you save, you can re-enter them into the system so other people can use your templates. This is a functionality we want to explore further later on, but this is not something we covered that much in this paper in terms of people collaborating on templates, just mentioning. And you have connections, so information flowing from one node to another to essentially execute whatever task you're given or whatever task you have. So to see how this system actually affects creativity, what we did is we set up a simple user study. We had 8 participants. Most of them were amateur writers or they didn't have creative writing experience. And most of them had also used AI like ChatGPT before. We gave them a character description task and a world building task. This is what an example character description task looks like. The way we constructed the study was we recruited them through convenience sampling. So we reached out through social media, saw what people respond. It's not the best way to conduct the study, but we didn't have any financial incentives or any incentives attached to the recruitment. So we needed as broad as reach as possible in this case. So there were 2 main confounding variables in how we wanted to conduct a study. One is, so we had, I think before this I should mention, we had a baseline, and that baseline was a conversational system that was using the same LLM in the backend. So to make sure that the order of interacting with one system first didn't affect the other, 4 participants got the conversational system first, and 4 got the graph-based system first. And another confounding variable was if you're asking someone to write a story about vampires 2 times, if they have already written a story about vampires, that might influence them writing the story about vampires again with a different system. So for a character description task, we slightly varied. We had 2 variants, and these variants also were different for each system, and they average out to 2 participants per combination of order and variant. So that was how the study was designed, and yeah, to evaluate the outcomes, we had a Likert, we had 4 questions on a Likert scale with some on a 5-point Likert scale and 3 open-ended questions. We performed a thematic analysis of the 3 open questions, and the study for each participant lasted about 1.5 to 2 hours, and it was done online. So they had access to the interface through web page, essentially. And these were the questions we asked for the evaluation. So how satisfied they were with their completion of the task, how significant they thought the system, how significantly the system they thought had affected their task answer, how easy it was for them to use the system, and how collaborative they thought they were with the system. So these were the quantitative questions, and the more qualitative questions were the comparison of the writing process between the two systems, any aspects they found particularly useful, and any aspects they found particularly frustrating. So based on these questions, we got the following results. So quantitatively, you don't actually, it's a small sample. You don't really see that many differences except in the ease of use, in which case our system was significantly more difficult to use. And there is some difference in significance as well. So the graph-based system users felt was more strongly affecting their final answers. And that could mean that maybe there is something here in terms of it being it being a more relevant system to interact with. But these, except for the ease of use, these can essentially be noise. And the more interesting results were the thematic ones. So many users found that they were able to conceive more ideas with the graph-based system. And there were a few users who also had, those who had difficulty, those who actually found the system difficult, prefer the chat-based system. So one of the participants, I think P4, was unable to interact with the graph-based system. She was, they were the one who hadn't used AI before, one of the participants who hadn't used AI before, and they were still able to use the conversational system, but they were not able to do anything with the graph-based system. One of the interesting quotes within this that I would like to highlight is what P8 says on over-reliance. So some users some participants noticed that the way that they were interacting with the conversational system made it so that the conversational system was essentially taking over the process. And that means that you have this system where you're asking it questions, it gives you answers. And in some sense, because you don't have the conditioning to explore, right? If you have a graph and you have an option to just pull out something and make a new node, you might be encouraged to explore more. Participants also liked that they could structure the graphs in a more complicated way compared to something like a conversational system. So this is on the contrasting user experience based on how much I felt experienced they were with graph node systems. So you have people who, well, you had the user who wasn't able to use it at all, and you had a user who was able to, who found it very intuitive and easy to use. And this is partly because our participants were from, some of them were from a tech background where graph node systems are more common, and some of them were from a more casual background where they haven't seen these kind of systems before. Now, there are a big amount of limitations in the study, only 8 participants, mostly amateur and hobbyists, so the results don't generalize at all, even because they don't generalize, and we used convenience sampling, there were time constraints, and there are limitations to the system itself. These are highlighted in the thematic analysis, but let's go back to the question of, do conversational interfaces limit creativity? And in some sense, I fooled all of you because I don't really answer this question in the paper. But it does point towards the fact that there is a rich possibility of interfaces that, and the thematic analysis suggests that for certain aspects of users, because of how I feel like conditioning works, you can have some limitations of creativity. So it's more of a starting point than, oh, we've answered this question. In terms of future work, we could have better evaluation, obviously, and the system itself could be improved. But what I imagine myself working on more is exploring the templates that the system allows for. So having this system in a context where people are sharing their prompts and building on each other's prompts more. I just want to ask how much time I have left, so I can, 3 minutes, good, okay. So I think it would be instructional to show you the system in action if it works. Let's see if it works. So this is how the users were presented with the system. They had a user ID based on a logged into the page, and they were presented with the graph node system. They have a task on the top right. That's the task the task is given to them on the basis of the user ID for the purpose of the study design. They have a task on the top right, and they have the ability to drag nodes into the user interface. You can prompt nodes, and you can connect them with one another. Because we had time constraints on how much time we wanted to take for participants, we also provided them with custom templates that we encouraged them to expand. So this is an example of a template. You can load this in, right? And this represents work that somebody has already done in understanding an area of a problem. So for character descriptions, you could make a template, and many people can use that same template if they spread it around. So if I run this template, I still have time, right? If I run this template, each node runs systematically, the information is propagated, and you should see an image here, because this is an image to text node, and each of the values is updated. Does anyone have a character they would like me to just generate just to see what we get? Anyone? No? I'm just going to type in something that I've typed in before then. Villain, vampire. And based on this input node, you can run the system again, and it propagates the output throughout the system, changing everything in between. So I think what would be most visible to you is this image. And this image should change to something like a vampire. Hopefully, Stable Diffusion 2 is not as good as what we have right now, so I don't know what it's gonna. That's kind of a vampire, an evil vampire. So that's how the system looked like. While interacting with the system, we asked the participants to write notes, record their stories, and once they were done, they submitted it and moved on to the next task, which was the interaction with the second variant of the character description task in the conversational interface. And if you had a different user ID, you were given it in a different order, right? So you would have the conversational interface on a world-building task first, and you go through the same process. There's a survey at the end. They go through the survey. That was the study design. So I think that'll be it, and I'll answer any questions anyone had.
Thank you very much, and thank you very much for a live demo. Could you go back to that template, the template you just showed?
Oh, no. I can, but just 1 second.
I just wanted to see if you could explain a little bit about what is there, like why it is structured the way it is for that template. Yeah.
Yeah. So I'll just say before that I'm not an expert creative writer. So the templates were just my experimentations, and in some sense, the focus of this is less to look at creative writing, but more to look at how creativity differs between the two systems. But I'll explain what was in the templates, for example. So for example, for the character description template, you could describe the character's background. That was the first one. This background goes into context for describing 4 central feelings or emotions that the character might have in another node. There's a prompt about a unique personality trait they might have, and this is also informed by the character background. So that's the kind of stuff that was in the template. Yeah.
Very cool work. Just to clarify, so information propagates along the nodes, but so if a node is not connected to a particular, it doesn't know what the information was that.
Yeah, it's all, so if you don't connect nodes, the information stays within the node itself. There are future directions where I was thinking about having some global context, because that could be interesting as well, looking at how that affects each of the nodes, but I didn't get time to explore that direction.
Thank you for sharing. Really interesting, and also something that we've been thinking about a little bit ourselves, because I think your intuition is right. The linearity, the sort of one universal true timeline of a chat interface is hard to go back and sort of diverge from and create a multiverse space with. We've played around with that in UI space, but then graph interfaces kind of give, I think, a better intuition there. The perhaps interesting challenge that your sort of study design sort of presents for me is template interface for the graph UI sort of guides someone through the process of how to do this in this interface.
Yeah.
But would a chat template be equivalent of teaching someone how to successfully chat in that space? And just sort of thinking about, I guess, the imbalance of UI sort of tutorialization that's happening there. So just love your thoughts.
So you're talking in context within the study design? Yeah. So I tried to, what you can say, go over some of that by giving like example queries relevant to each of the prompts. So obviously you can't eliminate, they have more information, more variety with the graph system, right? Because the templates are more defined. But I tried overcoming some of that. On just having chat templates themselves, I'm exploring that kind of in another project, and I'm not sure if it'll go anywhere, but we'll see about it. Is there anything you want to add to that? Or I can hear you. So.
Okay, well, I think it's for the streaming purposes. The graph interface, I think, immediately lands you into the space of you have the ability to be multiversal, and the template sort of exposes you to that.
Yeah.
And a chat interface, even in a template structure, doesn't really show that you have the option of going back and changing things, even if you could.
Yeah.
And so I think it's the perhaps seeding of the thought of you don't have to be stuck in this singular flow. You can go back and change things, and how that UI, UX sort of pre-position someone's cognitive state of like, oh, I'm going to explore as compared to I'm just going to do one thing.
So just an extension to that, I think you could have chat interfaces where you click a button and it becomes a graph, and maybe that achieves some level of that preconditioning that we're talking about. But it's an interesting direction for future research. Any other questions? Yeah.
Hello, Abhinav. So first things first, congratulations on the presentation.
Thank
Very,
you.
very nice. So my question is actually pretty simple. I just wanted you to go back to the previous assignment on the demo.
On the demo, yep.
Yeah, for to the template.
Yep.
Yeah, so when you load the template, I noticed that you have like different colored points on the node. Can you just load the template? Yeah, so what are these different points? Like, they look like entrance points to the node, and I wanted to understand like what are the difference between them, like because I see one point, for example, connected to the input node. Like, how can I?
Yeah, I'll explain it. So, a prompt. I mentioned very briefly in the slide the different kinds of nodes. So, for some nodes, you want to have the ability to pass in additional context. For some, you only have the ability to pass in the prompt itself. So a yellow point indicates you're passing in a prompt. If you hover over them, you see context. So connect to pass prompt, connect to pass an input, in addition to connecting to passing a prompt. So they're just different visual ways to indicate what you're passing to the node. And theoretically, you could have a variety of different ways you organize this. This is just what I chose. Yeah.
Thank you very much.
Yeah.
All right. Thanks again for the presentation.
Thank you. Oh, the code's available on a QR code, or if you look at the paper, there's a GitHub link.
You tell me when I can start. Can start already? Okay. So, hello guys, good morning. My name is Louis Zerkowski, and I'm here on behalf of my team to present to you my paper, Invisible Strings, Revealing Latent Denser-to-Denser Interactions with Graph Neural Networks. Yeah, this is the result of my work during Google Summer of Code. This was a partnership with the Human AI Foundation at CERN and also the partnering lab at Northeastern University. Just to go very quickly on my team. So a little bit about myself. This is me, Luiz Zerkowski, born and raised in Brazil. I have a bachelor's in computer science here at USP. I worked at ETH for a while, and I have finishing up my master's in AI at the University of Amsterdam. And I worked a bunch of different labs and companies around the world. And now a little bit about my team. I could not have done this work without them. So yeah, this is Zishuang, my coworker. She worked on her own project for GSOC2. Yeah, she's a software engineer now. This is Ilya, one of my supervisors, PhD in performance philosophy, assistant professor in dancing at the Northeastern University. Amazing guy. And this is Mario, my other supervisor, PhD in physics, a machine learning expert, and yeah, a researcher at the Berkeley lab, also a dancer. Now let's get to the project itself. So just to introduce everything to you guys. So one thing that probably you guys heard of, and actually very much in this very conference, a lot of people talking about dance, they always talk about how dancers have this difficult time interacting with technology, either because we're scared of how technology will make creativity a little bit harder or overcome their own creativity, or just because they don't know how to use it. So the idea of the project is exactly to bridge the gap between dance and technology by studying and visualizing subtle physical dialogues in partnering. That was the idea. To do that, we extracted 3D poses from curated duet videos from the partnering lab, which Ilya runs, with a dedicated video-to-pose pipeline. Then a graph neural network was trained on 3D poses to predict the weighted connections between dancers. And of course, we aimed on using the learned connections to offer new insights to partnering studies and interpretability of movement. Just to give you a quick heads up on what the outputs of the project look like, this is one of the gifts that we have. Of course, I'm gonna go a little bit deeper into that later on. Yeah, but I really like them, so yeah. I just wanted to show you a little bit. So for the first part, we start with the pose extraction pipeline. First, we compared a bunch of open source tools, both 2D models and 3D models, and selected the Alpha Poses hybrid for its more accurate and multi-instance 3D pose extraction. So just to show you a little bit of the outputs again, this is what raw output from the 2D pipelines look like. This is not that bad, of course, but we quickly realized that for the dance context, losing the third dimension, when we dropped the third dimension, we actually dropped a lot of information, especially regarding how dancers connect. So that's why we moved on to a 3D pipeline. And this is what the 3D pipeline looks like. Of course, this is raw output. Can you see it? Yeah, okay. Of course, this is raw output. And we're not working with mesh. Actually, we're working with skeletons, but we can also visualize the mesh on the pipelines that we were using. As you can see, though, it's very, very noisy. And because of that, we had to work on a whole processing pipeline. Yeah. So we denoised the outputs by interpolating missing frames, matching identities when we had dancer swapping, and especially this last part, we had to do a bunch of smoothing because of the jitter. And we did that with a 3D DCT low-pass filter. So just to show to you, this is what the raw output, well, we are getting just one dancer here. We are extracting one dancer. This is what the raw output looks like on the left. And this is what the output looks like after a whole processing pipeline. So it's not perfect, of course. We did not have the hardware to actually get the 3D position of dancers with the whole equipment that the dancers use those dots on the bodies, of course. So we had to work with the videos. It's not perfect at all, but yeah, it's what we have. So going to the next part, we start talking about the model. So first part on the model is the data, of course. So we started by loading the process 29 joint skeletons for each dancer and constructed fully connected and directed inter-dancer adjacency graph. This is what we used as input for the model. So this is what a random frame looks like with the two dancers. Oh, if I use this one, yeah, okay. So if this is what the input looks like for the two dancers on a random frame, and this is what we actually wanted to input to our model. So these are like the fully connected dancers. You notice here that we're not connected like within themselves, we're just connected to the other one, right? But still, this is a very complex problem. We have so many edges here. We have 29 joints connected to another 29 joints, and we're bidirectional, right? So we have like, you have them in two directions. And because of that, we did not have the computational power, nor the architecture was that good for that. We had to reduce the problem a little bit because we did not have the time to fully explore the potential of it. And because of that, we subsampled the joints on each dancer to reduce the graph complexity and enhance learning. So in the end, this is what the input actually looks like. We're just sampling joints from the dancers. In this case, I bring to you only 4 joints, but we actually sample 5 joints from each dancer, so 10 joints in total, and they're fully connected, of course. Now let's get to the architecture. I'm not gonna go super deep into that, but just to tell you a little bit about it. So we framed do-it interpretability as a graph structure learning problem, and we used a variational autoencoder-based architecture to uncover the joint-to-joint influences. We made use of graph convolutional operations and graph recurrent neural networks with custom GCN LSTM cells that I implemented for the next frame reconstruction. So, explaining a bit more with the image, this is what the architecture looks like. It's heavily inspired in the neurorelational inference paper. It's just like a modified version of it. So please check that out too. So just to tell you a little bit about it, we start with the initial sequence. So this is what we're trying to predict the edges for, the connections between the dancers. Then we do a bunch of node-to-edge operations, a bunch of convolutional operations too. I'm not gonna go super into that. And we end up with like this latent space that we're gonna sample edges from afterwards. And then what we do, we use these new sampled edges back on the original sequence to see if we can reconstruct the next frame in the end of the autoencoder. So just to explain it a little bit more intuitively, think about having 2 dancers connected to, well, they're dancing together in partnering. If I sample, suppose that their hands are moving together. If I sample an edge connecting the head of one dancer to the waist of the other dancer, probably when I try to reconstruct the next frame, I'll probably get the position of the hands wrong because the information is not flowing from one dancer to the other one because I'm connecting head to waist and they're not moving those parts. But on the other hand, if I sample the correct edge, for example, the right hand of one dancer and the left hand of the other one, probably the information flow is going to be a little bit better, and I'll probably predict the position of the hands much better. So that was the idea of the whole pipeline. Yeah, so this is what the architecture looks like. In the end, we also benchmarked the model on a simplified charged particle dataset just to assess its ability to reconstruct trajectories and predict multi-type edge, because 3D dance duets is a very, very hard problem. So yeah, this is what the results look like. We start with the charged particles dataset. So this was the benchmarked dataset that we used just to validate architecture. So on the first row, we have the originals. So this is the original trajectory, and this is the interaction graph for it. And this is what the predictions that we get. So we actually get 2 of the edges correctly, and we get 1 wrong here, and we are missing a few. But we probably got the most important interactions. And we know that because when you look at the prediction, even though localization is not perfect, for example, the orange particle, but the movement of the particles is very much similar to what we had on the original one, right? So it means that our network is actually learning, it's actually able to predict position, and therefore probably the edges that it's sampling make sense somehow. So then we go back to the 3D Dance Do It. This is what our output looks like. Don't notice the jitter that much here. It's because we are not using the output of the model as the input to the next frame prediction. We're predicting independent frames. And because of that, the localization is on average correct, but it's very noisy. So don't pay that much attention to that. And we didn't want to cherry pick results. We wanted to show what an average output of the network looks like. And this is the interaction graph that we predict for it. Yeah. Now, just showcasing a few more results. The interesting part, the interesting thing about this part is that we actually had a dancer supervisor. So we had the opportunity to talk with him about what we're actually looking for when talking about partnering, right? And we noticed that the network was able to predict some trends that you normally see in partnering indeed. For example, opposition tendencies is very common in modern dancing especially, to have partners either moving further away from one another or moving towards one another. So in these opposition tendencies, and this was very much captured by the model on a lot of different examples. It's very cool. Another thing that we realize is that quite often we have high joint incidence. So one joint either influencing a bunch of other joints or one joint being influenced by a bunch of other joints. I like this as an example here very much. This one is the first one that I brought to you on the initial slide. Basically, we have the feet of the blue dancer influencing the torso of the other one, which make total sense here because, well, the blue dancer is moving forwards and the torso of the red dancer needs to go back a little bit, right? So it feels like the extremities of one dancer should be influencing the core of the other dancer indeed, right? And just to bring a few more visuals, just because we're very cool, these are some other examples that we have. This one to the right in particular is one that I like a lot. You see the hands of the blue dancer influencing how the red dancer feet are moving, which makes total sense for the movement we're doing. But not only that, it feels like a puppet master, right? Like basically deciding what the red dancer is gonna do. So yeah, that's pretty much it for the project. Now let's talk about the future of the project. Of course, we need to expand the data set and refine 3D pose pipeline with normalization layers. Yeah, we got some great results. We got some at least interesting results, but it can get so much better than that. And we struggled a lot with the data set. We did a bunch of augmentation, rotating dancers on the z-axis, because it doesn't really matter where they're facing, right? If you rotate them together. But it was not enough to make the whole pipeline work, for example, for the fully connected graph, right? Yeah, and normalization layers too, but I'm not gonna go super into that right now. Then we need to explore more NRI variants and other architectures too to boost reconstruction reliability. When we were working on the project, it felt like every time we had a next iteration on the architecture, it always made it better. So it feels like we haven't reached the sweet spot of what the potential, the full potential of what NRI architectures can do here. We need to batchify sequential steps. As I told you, especially the GCN to LSTM custom node, I implemented it. So yeah, I did not optimize it at all, and it took a long time for the network to train on that graph recurrent part of it. So yeah, we need to batchify it, and most importantly, we need to introduce the tool to more dancers, because the idea of the project in the end is to help dancers study interactions in partnering and just understand a little bit more about themselves when they're dancing. And if we had interactions with our supervisors that were dancers, but interacting with more people in the community would benefit the project a lot. That's pretty much it. These are the main references that I bring here. If you want to check out more references and the full paper for technical details, please do that on the QR code. And thank you very much for your attention. If you want to contact me, please do so. These are my, basically the my links. Thank you very much.
Thank you for the talk. Very interesting work. What's kind of funny is I picked up on your sort of heavily leaning into the machine learning, the modeling, the network architecture, all the stuff of getting the system to work well. But then your future, this idea of being useful to human dancers. And so it seems like you're going to have to transition from being heavily in the ML heavily into the UI UX. It's going to become an information visualization problem. I'm wondering how you're thinking about sort of engaging them and saying, we have all this rich information the machine can detect, but how do you want this presented to you in a way that is useful to you? Because whilst I can read the dancing dots with lines connected to them, and I've made visualizations like that many, many times in the past, I'm guessing that's not the most intuitive UI for the dancers. And so I just wanted to get your thoughts on that.
Yeah, thank you very much for your question. It makes total sense. So to be honest, when we think about, at least when I was discussing interactions and future work with my supervisors, they actually liked those kind of visualizations quite a lot, especially my dancer supervisor. So we haven't thought about how to introduce it in another way. What we thought of was building this pipeline for real-time interaction. So it would be basically kind of the same thing, but just being done in real time and showing to the dancers as they dance how they're connecting to one another. This was, at least for our dancer supervisor, which was Ilya from the partnering lab, he said that he always pointed out that this was a very cool visualization. And I think that as a team, this is what we thought moving forwards regarding interacting with users. So not as much like a lot of interaction with the system, but rather at least seeing what the system is outputting and then thinking, reflecting on it. Yeah, that was the idea, on real time, of course. Yeah, go ahead.
Thank you for the presentation. I think it's really interesting. I just had a question on the latent space that you had. Did you perform any kind of dimensionality reduction or some kind of, there are various methods to look for hidden features in latent spaces. Did you find any thing there, or you just asking?
That's a great question. So our latent space is actually a little bit different from what you expect on normal latent space. Okay. So we are not, we don't have it doesn't make sense on our latent space, but okay. Let me go back there and I'll explain it to you. It doesn't make sense in our latent space to explore, to explore the latent space a little bit more because it's a categorical latent space. And then you can say, of course, but then how can you do it if it's a categorical latent space? Yeah, but we use a distribution, a continuous distribution that simulates a categorical distribution in the end. So the whole pipeline is differentiable and therefore is trainable. But so still the distribution is very categorical. And because of that, there's not much you can do in terms of exploring it, you see? What we do here is basically sampling different types of edges. And then different types of edges basically tell you how strong or weak the connections are. And sometimes, this is a very exploratory work still, but sometimes one type of edge is more connected to opposition tendencies. The other type of edge is more connected to other tendencies, so on and so forth. But it's more about categories than actually exploring it. Yeah, but thank you for the question. Very good one.
Yeah.
He's on.
Hey, have you thought about like considering floor interactions to like floor connections? Because I saw you have like dance partners, but they are always on the dancers would say on the high level, like standing up. But dancers, especially contemporary dancers, really like to go down and like roll and like stuff like that. And how could that like influence your system too?
Perfect question, makes total sense. To be quite honest with you, if dancers are doing very extreme movements like rolling on the floor or something like this, probably the video to pose extraction pipeline wouldn't work as well. So we probably would have to smooth the movement somehow. Having said that, it was it worked quite well in general. And we do have some ground movement here too. Let me just go back to the results. Sorry. Yeah, and here, for example, in this first example here, on the left, we're actually sitting down and moving towards one another. So we do have kind of a high variety of movements. The thing is just we cannot afford losing track of the points that much. Yeah, so like the hardest parts are always when we're like passing in front of one another, and it's a monocular view here, right? So that's the best we can do here. We cannot go much further than that, right? Yeah. Please.
Yeah, I thought a great talk. On the previous slide, you know, you got the predictive move, where you actually predicting the next move.
Sorry, can you speak a little bit more
yeah.
to the, yeah.
Yeah, so on the sense where you're this slide where you're predicting the next move, that one there, could you predict so we go back to that one again.
Is it in the architecture or this one?
No, it was actually the one where you did the machine learning stuff and you predict the rest,
so the architecture itself.
Yeah, the architecture itself.
Okay.
So on
this one.
So when you reconstruct the next frame, have you kind of considered the thought of restructuring the frame after that and the frame after that to add suggestions to dancers to try different moves? Yeah.
We actually have. We really wanted to do that, but we do not have the time because in the end, Google Summer of Code is a program, at least in my case, it was a 4-month project. So we developed all of this infrastructure in 4 months. And we really wanted to do that. Actually, the first thing we wanted to do is just to use the next frame as input for the next frame.
Yeah,
because if you do that, at least you get a more stable reconstruction. This is the least we were expecting. But getting that to interact with dancers, it would be even better.
Yeah,
and one of my supervisors, Mario, actually have a work on that too, on this generative pipeline. And it's very cool. I really suggest you check it out too.
Yeah, because that's all really cool. It ties in with like neuroscience in a preemptive kind of sense where you're actually preempting the next step, way ahead of actually doing the next step. And so if you detected like 10 steps ahead, for example, you could say, well, I could move into this space instead of, so do something really kind of cool. Yeah.
Yeah, it would be super cool. I totally agree. Maybe if we can develop the project a little bit further on another project or something, it would be amazing. Yeah.
Yeah.
Thank you for the question. Thank you. Any more questions?
All right, let's thank the speaker again. Wonderful talk.
So back to the original plan. Thank you very much, guys.
So we have to go back to the original plan. We assumed that the first speaker of the next session would be here, but she's not here. So we'll have the coffee break, then we have a presentation and the closing session. So original plan. Thank you.
No connection. I'm assigning a value to the edge to each edge representation and sampling from which category it belongs to. That's what I'm doing. It's very complicated, right? Yeah.
It's very nice, actually. It's very interesting.
Yeah, I think it's very interesting too. But whenever I have to explain it to other people, it's very complicated because it's not the normal way of implementing a rational encoder, right? You normally don't.
That's how you make innovation.
Yeah, that is true. That's true.
Because in the more like RL conference, RL, the machine learning conference.
Yeah, that is true. That is true. Yeah, thank you very much. If you have any
Okay, so hello everyone to the last session of this conference, and actually also to the last talk of this conference, because there's only one long talk in this session. And this talk is given by Ina from the Creative Computing Institute of the University of Arts in London. And so, stage is yours.
Yay. So just press this, yeah. Yeah, cool. Hi. So my topic is in AI and fashion. It's quite different from everything else so far. It's quite visual, less statsy. It's called Co-Designing Fashion with AI, and it's a small data approach to generative garment design. So essentially it goes from the sketch to the end product. This is a general research outline. What I was researching was essentially just how to help small designers prototype without actually having to physically make the garment. And I researched to what extent small-scale personalized fine-tuning, as opposed to like using large models, can help with prototyping for sustainable workflows. It's also all based on ethical data usage, so we only use the designer's data and my own photography data. This is the workflow. It's all informed by co-design principles, as by McCurha, who is a researcher specifically for like working in collaboration with experts across fields. In this instance, it's me, the developer, working with a fashion designer to come up with a workflow to create the prototypes. So essentially, each stage of my project, I would go back and talk to the designer about whether the outputs were what she'd imagined, or like if it was something that she would consider her own designs. And if it wasn't, I'd go back and like change the way the designs were generated, essentially, until the final result. I did 3 experiments. One of them is sketch generation. So I trained a model, like fine-tuned a model on her sketches, like the designer sketches, to generate designs that look like her designs. Essentially, you'll see later like a bit of a sketch bod, I suppose. And then I fine-tuned realistic vision on my own photography to change the textures of the outputs and make it look a bit more realistic, which is important in fashion. If anything looks too like dull or like polished, it's not really good for fashion photography. Oops. So the generative sketches, I fine-tuned Stable Diffusion version 2. I used the dream booth technique, which is a technique you use if you want to only use small data. You only need about like 20 to 80 pictures to get good results with it and to change the visual aesthetics of the outputs. For this run, I used 29 original sketches of the designer, flipped these for data augmentation, and this is a sample prompt, so like a description of the sketches of the designer, so a front view of a pencil sketch mannequin of athletic build in an all-chic outfit. So it's kind of descriptors of the body type of the mannequin and also the clothes specifically. These are the sketches that the designer gave to me that I worked with. They're all supposed to be kind of gender fluid and like inclusive of all identities. And these are the generative sketches. So you can see that the drawing style has been really like well adapted, and it's like it resembles the drawing style of the designer quite well. That's after 600 to 800 iterations in the training run. Anything beyond that suffered from quality loss. So 600 to 800 was kind of perfect for this one. This is an example of this design over here with the pleats. You can see that the model adapted the way the pleats are done really well. So like the model's quite adaptable to her style. And the one below that is unseen data. There was no leather in the data set, but the sketch here is quite structured as it usually is with leather garments. So it's like the kind of generalizability of the model. A quote from the designer about the sketches, which is quite important in co-design, because it's like shared power, and like I'm learning from the designer and she's learning from me, and we're working on everything together. And here she said that essentially the sketches really resonate with her, and that she really sees her own style in it, and that she can clearly recognize her own style, which allowed her to appreciate her own work more. And then I did essentially a similar thing for the visual identities of the photorealistic outputs that I'll show you in a second. I used my own photography, and we kind of aimed for an urban aesthetic, so quite rustic. A sample prompt is like similar to with the sketches. It's just describing the scene and what you can see in my pictures to teach it through the model. It actually didn't work super well with the caption training, but I'll talk about that in a second. This is the data set for the photography. It's all in urban settings. The textures are all quite worn, and there's like a certain visual identity to all of these, which is what we wanted for this like fashion campaign specifically. This is the captioned versus the uncaptioned training run. So I fine-tuned the model once with CSV descriptions and the other time without. You can see the middle one is quite incoherent. So the model got a bit confused with, I assume, my descriptions. I tried a good few different ways to prompt it, but every time it would just kind of like give me these like quite incoherent results that you can see in the middle. The first one is the realistic vision model that I hadn't fine-tuned, and it looks quite polished. Like it looks quite like just artificial. And then the last one is the ones that I trained, but I didn't have any captions. And you can see that it looks quite similar to the first one, but it looks more worn and like a bit more realistic, essentially. This is a further example of that. The lower ones are the realistic vision model without fine-tuning, and the upper ones are mine. You can see that the shadows are more realistic, more refined. The textures on the wall are more realistic, more one-off, a bit more urban. And then same here, where the lower ones, essentially if I gave all of these the same prompt about standing in an industrial corridor, and the lower line of pictures is the realistic vision output, and it always puts her in the same setting. It never changes. So like she's in the same corridor every time. Whereas with the fine-tuned output, there's way more variety in outputs and settings. This is a quote from the designer about the backdrops, which is kind of reinforcing that uncaptioned training is better for this instance, because it needs a more it needs a more neat backdrop. If it's too messy, that doesn't really work for fashion. The cloud should be in the center, should be the focus of the photographs. So you want to keep it quite simple, but you also, the fine-tuning achieves kind of like more visually interesting and stimulating aesthetic, which is equally as important for fashion and kind of emotional richness. This is the control net, which I used to fix the designer sketches, because control-net scribble turned out, control-net scribble is essentially, if you have undefined edges, it works much better. The lower one is the control-net scribble. And you can see that the lower edge map is like less defined, like less kind of identifiable. The model struggles to actually like read the lines within the edge map. So, oops, control-net Canny didn't really do that well with it, and like kind of went a bit like beyond the lines, didn't really fix the structure the way that we wanted it to, whereas control-net scribble kind of like works with the undefinedness of the edges. So you can see in the picture with the purple trousers, it didn't really understand what the edges were, but it kind of tried to work around it and come up with a solution to make it look similar to what's in the picture. So if you look at the trousers, you can kind of see this detail that's like not intended by the designer, but it's like trying to come up with a solution to like stay in line with the edge map. The upper one is way more defined. You see sharper lines. The whole design is sharp lines. And control-net scribble can't really do well with that at all. It just kind of goes quite abstract and doesn't really keep to the structure of the clothes, doesn't keep to the patterns at all, which defeats the purpose in this instance. And the one next to is really similar to the edge map, and Canny is really good at like structuring the outputs around the edges, so it works really well for defined fashion sketches. Another thing was that for AI in fashion, it's quite important to stay in line with the designer's visions. She didn't want leather trousers here, so negative prompts are essential to achieve the results that you want. I could have used segmentation, and I will use segmentation in the future. This was just kind of an experiment to like figure out how negative prompts can help with like achieving the visuals that we wanted. So putting in the negative prompt leather trousers fixed this pretty well. Jacket is still leather, and the trousers are like suit trousers, which is what we wanted. And then same here, this is about the polka dots, which are like necessary in the shirt, but it just kind of like puts polka dots everywhere if you put in polka dots into the prompt, right? So working against that with like specifically what you don't want polka dotted leads to the best result. These are the final outcomes, which the designer was really happy with. The one with the orange shirt is an interesting one because the trousers kind of have like a little yellow artifact that the AI obviously came up with, at which point the designer was like, that's actually really cool. It's not really what I envisioned, but if I actually make these clothes, I kind of want to hand paint them. So she was like, sometimes when I see these designs that your model is giving me, it's giving me inspiration to like add like stuff in terms of the design of the clothes, like hand painting. And then the takeaways from this are, I think AI is a great support tool for fashion, like creativity support for fashion. Small data is a valid approach to AI, and especially using AI within certain design industries. And yeah, inclusivity and sustainability in design. Like we try to do the genderless clothing and like include all identities, and because it's small data, I'm like, this is for future research, but my hypothesis was that it could be like slightly more sustainable way to do AI. For that though, I should definitely conduct life cycle assessments to measure the carbon footprint with both methods. The idea is that the designer doesn't have to do physical prototyping, hence reducing waste in the process of that, and by using small data to reduce the carbon footprint of actual model training. But yeah, a life cycle assessment for this would be necessary. This is also, it's a case study. I did it with one designer. I'm interested to do it with way more designers and see like how far it can go in terms of like visuals for different designers and what they're imagining. And AI's ability to generate realistic garments is ever evolving. I'd be interested to kind of experiment with material libraries, train models on like all kinds of materials, because it's kind of still falling a little bit short on that. So that's definitely something for future research as well. Yeah, it should be a collaborative process where both parties, the designer and the developer, respect each other's expertise and have a conversation about how to achieve the outputs that are desired by using AI. This is a little AI animation I made with the designs at the end. It's literally 12 seconds. It's just a fun little thing. But yeah, it's just kind of bringing the designs to life, which like, we're still working on this project now. She wants to actually make the clothes, and I want to create a fashion show using AI. So that's the thought behind that. Thank you very much.
So thank you for a really interesting talk. Are there any questions?
Really nice presentation. I was wondering, in the aspect of the time to prototype, the time you have from the idea to prototype, and you mentioned that it already shortened the time to prototype, and you don't need to prototype physically. But I was interested in the cycles of iteration, but in the image generation sense. Like, how was the experiment with the iteration with the designer, if the sketches was translated almost immediately, or that time for processing or this kind of thing? And what do you think about these cycles and iterations?
Right. So it definitely turned out to be much more rapid than actual like physical prototyping, as I said. It took a while to get it right. It took a good while to get it right. I only did one training run for the generative sketches, but I did do like 3 different training runs for the photorealism one. Once you get to a point where the AI is actually doing the designs in the way that you want them to do, it's pretty rapid. Like the generations take like a second, or 25 seconds up to that, but it's pretty quick. I did it all in Python. So once you're at a stage where it's like at that point where you're happy with the outputs in general, then it's pretty quick. So it's like, it took a good while to develop the whole thing and like actually like make it work like that, but once it's there, it's kind of there.
But during the designer was sketching and then you were transforming almost real time, or do you have a batch of sketches and then you process and then you have another, was something interactive, or?
It hasn't been interactive yet. That's actually something that I want to work on, and I want to make it more interactive. I want to make it more interesting, and I kind of want to find like new ways of marketing fashion, and interactivity is definitely like one of the things I still want to do, but I haven't yet.
Hi, here. Thank you for the talk. Amazing work. Quick question, actually. So I like how like you're working with little data or low data regime. But I was wondering, like, how much does your model overfit to the original data set? Did you find a good, like, expressive range of different backgrounds, or it was mainly overfitting to the data that you already gave it?
So with ControlNet kind of like makes the outputs a bit more simple by proxy, especially if it's just sketches. It just imagines like a wall behind it because it's flat. You can use with depth mapping on top of that, which gives like way more like kind of like control over the backdrop as well, which I actually tried to do a few times, and it worked quite well, but I didn't include it here. This one here, I did ControlNet with fixed structures based on my own photography, so I kind of like got the designs into different backgrounds and had more control over the backdrops in general. So it's like with what I just showed you, it's kind of difficult because it's ControlNet and it's sketches, but using other techniques like depth mapping and like using real photography and like generating other like backdrops on top of the real photography, that works really well. So it's like kind of like you have to reach out to other techniques to like achieve that, but it's possible.
Thank you for the presentation, interesting stuff. And I'm curious because we kind of live in this period right now where it feels like artists and AI are sometimes very much at odds with each other. And so I'm curious, you had seems like a designer who was very open-minded and sort of considerate of like, let's think about this maybe.
Yeah.
I'm not just gonna shut it down.
Yeah.
Are you considering trying to look at how these methods, these approaches might help with those who are on the other side of that, who aren't open-minded or who maybe could see this as a way to enhance adaptability, acceptability, or just change the way people think about co-design with technology?
Definitely. So the designer I worked with, we've been working together on like her stuff for years. I've always done her photography for all of her projects. So she was really open-minded to helping me with my project. I've obviously talked about this to tons of different people and I get mixed reactions. And it usually like a lot of the time takes a bit of convincing where it's like, listen, this is like something that you can control the creative outputs a little bit. Like, I am a photographer and I can kind of make it look like what my photos look like. I can inform it by using your sketches. It's not so much like just the machine doing stuff in this instance. It's more about like using it as that creativity support tool and actually like visualizing stuff that aligns with the designer's visions. So I definitely would. I'd say it would be quite interesting actually, because she was quite open-minded. So in that way, she was also really open-minded to when it actually was a design that resonated with her. And she was like, I actually would market this as my own design. I can imagine other designers being a bit more reluctant to embrace it as quickly, but I definitely want to like work with a range of different designers with a range of different opinions.
Oh, I've got one question. Fantastic talk. It's basically about the co-creative process. Did you find that giving the designer one output or 10 outputs, did 10 outputs seem more overwhelming? Or if you give them 100 choices, did they find that more difficult to choose the best thing they want to work on?
Like me personally?
Yeah.
Yeah, definitely. I generated tons and tons and tons of stuff. But like even if I generate 10 at once, like chances are that like I like 6 out of the 10. And like 6 out of the 10 are like okay, and the designer likes as well.
Yeah.
But it's definitely quite overwhelming. When I was working on this, I ended up with so many pictures, like an insane amount of pictures, and like looking through all of them and sorting through all of them.
So basically, at some point, when you say you got 6, we think okay, do you kind of form a greatest hits of whatever the best ones are to iterative discussion between you and the designer as well?
Yeah, definitely. Yeah. So every time I generated stuff and I liked it, sometimes that wouldn't actually resonate with her. So she'd be like, actually, I don't really know about this one, but I'd have like a range of images and she'd be like, that one looks like what I wanted to do. That one doesn't.
Yeah. So basically, if you were 100 different images, then it's overwhelming in a sense. So you just narrowing it down to just a few of a similar kind of style, and then you say that's the one I want to take.
Exactly. Yeah, that's kind of how it works.
Thank you.
Yeah.
Thank you.
Are there any other questions? Okay, so let's thank the speaker again. And I think now we are continuing with the closing session.
Okay. Well, I hope you enjoyed this experience, the ICCC'25 in Brazil. I'd like to thank the Association for Computational Creativity for all its support. We had participants of 70 countries, 24 from Brazil, 12 from United States, 6 from England, United Kingdom, 4 from Portugal, 2 from Netherlands, Canada, and Australia, and 1 from Spain, Italy, Israel, Ireland, China, Sweden, Switzerland, Mexico, Slovenia, and Taiwan. We try to do our best thinking about a lot of details. I'd like to mention that the coffee you had was from my husband's farm and was classified as an excellent single origin coffee. I hope you like it. It was wonderful having you here, and I hope this interaction brings many fruits in the future. See you next year, okay? Bye.
Thank you. Don't join me then? Yeah, come on. This is a joint effort. Yeah, we just have some slides with some numbers. One of them, Artemis has just said about the number of participants, but let's thank everyone that made this conference possible, starting with the general chair, Pablo, who was here and that to leave earlier. The local chairs, thank you, Manuel, and thank you, Artemis. And Dante, Dante, why is he not there? It's not in the website, I think. Well, and thank to all the volunteers. I also wrote there, all the volunteers that were here helping with registration, with these technical issues. Thank you, Senor Gilberto. And thank you to all the team that was helping us back from their places that were not here, like Piera, José Pedro, Brad, and Marcio was here, always taking care of the website. And of course, this wouldn't be possible without the program committee, the long list of people that helped us review the papers and make the selection, all the authors. Thank you, all of you that came to Campinas, to this conference. And yeah, I think I'm not forgetting anyone. I might be, I'm sorry if I am. And of course, thank you to all the institutions that made this possible, that supported with all the expertise and the places, the technical part, and also to the Artificial Intelligence Journal, which made possible to have some more people participating with the grants, and also have supported the awards that will be announced in a couple of minutes. And thank you to Toyota Research, which also supported financially this event. So some very short, brief information about the scientific program. You know this, you've been here, so we had 5 workshops that were held on Monday. We had 11 paper sessions, almost 10, but in the end it were really 11. We had a poster session that I think went really well yesterday, and we had an amazing keynote by Jonatas. I don't know if Jonatas is here. We should also thank him. Well, apparently not. About the scientific papers, we had, as you know, 2 tracks, one track of full papers and a track for short papers. We had 61 submissions for full papers, out of which we accepted 24. It was challenging to all the high-quality papers and keep the trade-off between quality and the acceptance rate more or less in line with the previous editions of the conference. For the short papers, we were a bit more relaxed. We wanted to have different kinds of papers on different domains with more risky ideas. And so we had 58 submissions, out of which we accepted 30. And from these, we selected some for short presentation and 17 as posters. This had nothing to do about the quality of the papers. This was mainly based on the recommendation by the reviewers who thought that some papers were better suited for oral presentation and others for poster. And yeah, all the papers are available in the conference website, and the proceedings are almost ready. They should be published in the next couple of weeks. I think we are comfortable with this. Let's see if nothing strange happens. Yeah, this was already told by Artemis. Yeah, we had 65 full registrations, 3 people only registered for the workshops, and this 65 included 10 grantees supported by the AI Journal. These are the countries I only listed here, the countries with more than 1 registered person. And it was also really challenging having to deal with the reasons that we cannot control, most of them geopolitical reasons, but also health reasons that made it impossible for some people to travel to Campinas. Or some actually traveled and could not come to the auditorium to make the presentation because they were sick in their rooms. Let's hope that next year it's better. Yeah, and now some suspense for the awards. Do you want to talk about the awards, or should I continue? Okay, okay. So, yeah, you have the cast. So the awards, the first 2 awards, the full paper, the best full paper and the best short paper, are based exclusively on, well, we of course agree with this and confirm that everything was okay, but it's based exclusively on the opinion of the reviewers of the papers. Okay, and we have this amount, so these are sponsored by the Artificial Intelligence Journal. So the best full paper is Gaurav Sahu and Olga Vechtomova, Computational Modeling of Artistic Inspiration, a framework for predicting aesthetic preferences in lyrical lines using linguistic and stylistic features. They're not here. I don't know if they're listening to us in the YouTube stream. Maybe not. We'll have to contact them later. But yeah, so we can congratulate them. So the next one will be the best short paper. And the best short paper is for Samuel Shapiro, Jonna Black, and Lav Varshni, Transformational Creativity in Science and Graphical Theory. And yeah, he's not here. He's the person who traveled to Campinas, was sick in a room, and had to go back to the States. I hope that this award makes him feel better. And now I do hope that the person that will win the best poster is here, because all of the presenters were here. I know. The person is here. Who is it going to be? Please. Yeah, so it's Daniel, and Jackson, Travis, and Cynthia. No. Can come if you want. We don't have any paper to give you, but you'll have the amount, and we have to contact you to transfer you the money. But if you want to say some words, you did a great job presenting your poster. You convinced many people voting for it.
I will say the voting was close too. There's a lot of good posters, and in the end, we had one winner, but it was there's a lot of good posters and a really great session. So great job by everybody.
So I'll keep this short. I guess what I would say is that, so I've been to a lot of conferences in my life. This I probably can't count at this point, and I think without exaggeration, and I've told several people this while I've been here, this is sort of the best and community that I've met and been involved in this conference, and I really have enjoyed it. And so thank you, everyone. I think there's a lot of amazing work that's happening here, and a lot of amazing people, and I really appreciate it. And thank you.
Thank you. Yeah, and just before closing, most of you should already know, but next year the conference will be in Coimbra, in Portugal, in my hometown. So I hope that you can all come. These are some nice pictures of Coimbra. It's more or less in the center of Portugal. That is Portugal, and the red district or whatever is Coimbra. So it's time for the local organizers to pass the Cascavel to. Yeah, and there we have some. Yeah, we have some additional slides on Coimbra. No, okay, not necessary. Yeah, we have one. So I can. Yeah, it's being represented by.
Just in case people don't know, which there's no reason you should know, this little rattle was purchased in 2011 in Mexico City for the second conference. And we just got it to make noise so people weren't too long in their talking. And then it just started getting passed along, and it survived for 14 years. It's not an expensive, sturdy thing, but somehow it stayed alive, and it's been all over the world. And so now it's a symbolic passing of the torch every year. So it's kind of cool. And there you go. That's why we're doing this.
Thank you. Yeah, I hope to see you in Coimbra. Okay. You have the comments there. Não sei. Tem partilhou. Aqui? Aqui? É um vídeo? Não? Não? Onde está o PowerPoint?
Onde está o PowerPoint? No desktop.
So while they are preparing this, I can say a few words about Coimbra. We have one of the oldest universities in the world. It was founded in 1290, and you'll have a chance to see the old university. We have several buildings from the 12th century and others more recent. Is it? What happened? And so
Okay, sorry, I'll use this background. No, maybe not. Okay, as was already announced, the conference will be in. Does this? Oh, yeah, in Coimbra. Oh, there was a conversion issue. Okay, ICCC'25 will be in Coimbra, Portugal. This is an image of our university. Very old, as you have heard. These are the organizers of the conference, the Department of Informatics Engineering, our research center, in particular our research group, Cognitive and Media Systems, and with the support of the Intelligence Systems Associated Laboratory, which is a national-wide laboratory that supports intelligence systems. Okay, the dates. This is the key part. Please mark in your agendas. The conference will start on the 29th of June, Monday, and finish on the 3rd July, Friday. The submission deadline in principle will be the 26th February, so start preparing your submissions. It's almost there. It's a short time till February, so please submit good papers to the conference. Additional images about Coimbra. This is downtown to have a view of the architecture of the city. This is our river, a beautiful river. This is an image from the university. The university is on the top of the hill. Is like the castle of the town. the castle. Our castle is a university, and it is true. More images, a very old cathedral, medieval cathedral, built on top of a previous mosque. So it's really very old. And an image of the river of one of the places that we will certainly use to gather, to drink some beers, to talk and so on. It's a very pleasant place. Downtown, this is one of the main squares. You are not seeing, but here on the left, there's also a very, very old church where the two first kings of Portugal are lying. Lying? Okay. The tombs of the two first kings are there. Additionally, our university and additional areas of very old areas of the town were acknowledged as UNESCO World Heritage Site. This is very important for us and supported a lot the reconstruction and the maintenance of very old buildings. These are some of the places that are covered by the UNESCO Heritage title. You see the tower of the university down. The image on the bottom is a room where we can see the throne of the king, because Coimbra was during some time the capital of the country in the first times. So you have the throne of the king there, and the place where some of the main meetings of the kings with the nobles and with the church took place to make very important decisions. This is the library, the library, which is a treasure. The library, the chapel. In the bottom, you have an image of our garden, the botanical garden. It belongs to the university. On the right, one of the many images of our science museum. This is the physics area. And the venue will be in an old convent that was rebuilt recently. It includes a church and a big auditorium. We will not use the big auditorium, it's too big for 1,000 people or so. But we will make use of fantastic conditions, fantastic rooms, and gardens and so on. So it's a very pleasant place. I think you will enjoy it. And that's all. See you.
We still have the visit later. Chat, it's lunchtime at noon, and then I think if you're going to the particle accelerator, it's after that. Yes? Oh, one more thing.
Well, one more thing. Let's thank the organizers. Let's thank Artemis, Manuel, here. Let's thank these guys. Let's thank all the people involved in the organization.
Guys, thank you very much. We have here in the hall a little survey that's very important to us. So we will be grateful if you take your time to do our survey about our event, okay? And thank you very much, and see you at the CIDIUS, the Particle Accelerator. Bye-bye.